Think about a ball being thrown. The ball moves up as you throw it, and it also moves across the field. To predict the path of the ball, we need to break up the movement into two bits. The vertical component, up and down, and the horizontal component, across the field. This is called breaking down the movement into perpendicular components. It is used all the time in engineering and physics, and is an excellent example of a common use of trigonometry. Let's say that you throw a ball at 120 kilometers an hour, and you throw it at an angle of 22 degrees above the horizontal. The question is, what are the vertical and horizontal components of this initial motion? So our starting throw is represented by this arrow. It has a length of 120 and is 22 degrees above the horizontal. These two lines, one horizontal and one vertical, are called the vertical and horizontal components of our starting throw. We need to find these two lengths, x and y. That's the plan. Remember, in trigonometry, the sine of an angle is equal to the length of the opposite side over the length of the hypotenuse. So sine of 22 degrees is equal to the opposite y over the hypotenuse, 120. To get the y on its own, we multiply both sides by 120 and cross off the 120 on both the top and bottom on the right, which gives us 120 times sine of 22 degrees equals y. Similarly, for the horizontal, cosine is the adjacent over the hypotenuse. So therefore, cos 22 degrees equals x over 120. As before, multiply both sides by 120, cross off 120 on both the top and bottom, and we have 120 times cos of 22 degrees equals x. Now, we put this into our calculator and get y equals 44.95 and x equals 111.26. And there we go. Our initial throw of 120 kilometers per hour consists of moving across the field at 111.26 kilometers per hour and vertically up at 44.95 kilometers per hour. Of course, gravity will pull the ball down, so this will change over time. Do these numbers make sense? Have a look at the triangle. Does this triangle look reasonable? At a glance, the numbers seem okay. Neither of them seem too big, nor too small to be unreasonable. If we wanted to be very sure, we could check using Pythagoras' theorem. Give it a go and see if it adds up.